Well, hello. Um, Hope everybody can hear me. And welcome to my first attempt to stream live on the internet. Never done this before, and hoping to learn a lot from you. My name is Raymond. I live in the UAE. I live in actually in Abu Dhabi, and I'm an avid tinkerer and player around of equipment and hardware, and just love just playing around with the 3D technology and whatever it can do. Have been going for it for about 2 years, and I think I think it's something that either people love or they love to hate. So if you're watching this video and you're online or watching this in the future, the purpose of this video is pretty much for me just to, can I say, break the first entry into the internet world and just see what it's like, test my skills, and also at the same time, I've decided to build a RatRig, and not just any RatRig, the V-Core 3.1 and the 500. So I've chosen to build the biggest one, and it's quite a interesting decision process getting to the point where you decide which printer you're going to build, because there are so many printers in the market today, and to make a decision as to which one best suits you, you need to do quite a bit of research. I could only recommend to people that you do as much research as possible. Make sure that you do not just purchase the first time, and if you're going to purchase a printer, uh, maybe think about having a smaller printer first. Um, not everybody likes to battle. There's some good printers in the market, Bumble Labs, and these guys have really come in and changed the market quite a bit. I think the market is getting closer to, we can say, plug and print in that sense, because we're able to buy printers now, pull them out the box, take out the wrappings and all the little extra protection, and within half an hour to an hour, you're able to start printing. Whereas maybe 3 years ago, 4 years ago, that wasn't the case. We've moved a long way since then. But there are lots of different printers out in the market, and myself, I've got two other printers which you'll probably see during the feed just a little bit in the background. One being a Cartesian printer. The typical Cartesians in the market would be the Pruses and the Enders, the Crealities. I have a Creality. I bought a reasonable size Creality printer some time ago, and it's no longer a Creality. My nature is to tinker and to build and to improve, and probably the only thing that's left of the actual original Creality is the steel frame. From there, everything else has been changed. Controller boards, the printing heads, the motion system, everything has been upgraded on that printer, and that's been my go-to printer for quite some time. But you do get to a point where you start wanting to venture out if you're enjoying the printer and you want to print different types of materials. And while PETG and PLA have always been the go-to materials, a lot of us are wanting to now move on to a little bit harder compounds and harder to print compounds like ABS and ASA. And so the older printers that don't have enclosures are challenging, because the nature of an ASA printer and the nature of ASA filament and ABS filament is they warp a lot. They need to be cooled down very slowly, and while printing, they need to actually be kept at a very constant temperature. So how did I end up coming to this printer that I'm buying? Well, actually, I took my Creality, and maybe I can just switch over and you can just see it on the side here. Side view. So that's my Creality sitting inside this little tent, and I put it inside a tent, and it it's a good, nice printer, and it was printing very well. And you can see I've enclosed it. I put foil in, and I've got a heater inside there. But that's where the problem came in. So I I heat the chamber up to about 60 degrees Celsius to be able to handle the ABS and the ASA. Now, you don't probably have to go that high, but that's where I found was the sweet point for me with the equipment that I have. Unfortunately, you can think that that whole printer with all its electronics and everything is sitting inside um, a heated environment where electronics doesn't really like that heated environment that much, and all the components are running much hotter than what they originally were supposed to. So yes, I eventually got to the point where I burnt out the main board and the Raspberry Pi because something got hot, something shorted, and I realized that I've been pushing the printer just too far. Um, and so there's a lot of printers in the market that can actually do ABS and ASA, but you will notice that in those printers that the motors and the electronics and all the vital components sit outside of the heated chamber. And so I really thought, well, you know what, instead of spending a lot of money trying to fix this one and trying to modify this one, it's time to build a bigger printer in any case, to do a purpose-built print. And I will, as we go through this building of the RatRig, discuss some of the items that I really liked about RatRig. Obviously, there's quite a few other brands out there. The bigger guys are probably building Vorons as well, and Prusa's got their XL printer come out, and Creality's got their K1 printer out. But if you're going to build a printer, there's probably at this point 3 names that you'll come across very easy, being Voron, RatRig, and VisiBot. And for me, living in the Middle East, supplying and shipping everything and getting the right quality and taking the risk of having items arrive that aren't of the quality that I would like, I just didn't have the appetite to try and self-source and self-put machines together. And yes, there are Chinese-based companies now that actually do all of this, and they put it all into a neat package and send it off to you. But at the end of the day, you're still at the mercy of whatever they put in the box. And to get a response back from them is not always the easiest. I'm not going to say it's impossible, but it's not the easiest. And that's where I decided to go with RatRig. For me, living in the Middle East and having to import every single little item to the Middle East to actually be able to print this printer, it made more sense to me to go to RatRig and say, listen, this is exactly what I want. And they put the whole machine together, package everything that you want together in one box or 2 boxes or 4 boxes, whatever the case might be, and then they ship it to you. Super friendly, very efficient. Even had to change something slightly on my order. I sent them an email. They said, no problem, just order the stuff and we'll put it into the same boxes. And man, I cannot rave more about the support that I've got from them so far. So far, so good. Obviously, I'm in my early days of the RatRig, and I don't want to say that I'm not going to have hiccups. You know, I did a lot of research and I watched a lot of videos. There's some amazing guys out there, the likes of Nero 3D and Stefan, and maybe someone like I can't remember his name, from Australia, Teaching Tech. So those guys they've been in the market for a long time, and my idea is not to have a competition with them, but we have more people in the Middle East starting to look at printers, and I thought, well, I'd like to build a printer here and actually give people an opportunity that are in the Middle East or close to the Middle East area to actually have someone to contact and work with me, and then maybe I can help them with the design of their printers, or maybe I can build printer for them. So I don't know where this is all going yet. to me today is just about, and for this series, it's just about having fun and building a printer. I've got some friends that will probably come in and go out, and I've got Mr. Fig over there that will help me from time to time with some comments maybe, or help me with checking my equipment, because this is the first time I'm using OBS. This is the first time I'm actually looking at a Stream Deck. I'm running 3 cameras and wireless mic, which I only got today. So a lot of this is new, and maybe I'm going to have a lot of glitches and a lot of mistakes that I'm going to make along the way. But this is my home. This is where I learn, and I hope that by me doing this build, that I can maybe reach out to some people and actually have them also see that there's a lot of fun in building a printer like this. Part of sourcing the RatRig, I just go back to actual bring the RatRig. While RatRig will send you all the electronics if you want, I did order some of the electronics separately. I wanted slightly upgraded components to what they had on their standard website, just because I want to be different again, typical me. But they also don't typically want to ship you what we call the printed parts in ASA or PETG, ASA or ABS. So unfortunately, you can't order those printed parts from them. You can, however, order a PETG parts. Right now, let's quickly just define what's the difference between PLA, PETG, and ASA and ABS. Well, at the end of the day, it goes to me about temperature. When I'm building this printer, I'm going to be heating up this enclosure, and so I'm going to be modifying this printer from the standard RatRig to build heaters inside it to heat it up. And both PLA and PETG have a negative threshold of when they get to 50, 60, 70 degrees, they start deforming, right? And you don't want to push a plastic close to its limit. With that, PETG would maybe be close, but if you're going to print even higher temperature items, where your temperatures can go a little bit higher, and if you're going to be printing on the verge of 60 degrees the whole time in a PETG printed enclosure, you're probably going to be bordering on the equipment failing with time, the actual fittings and that changing shape, expanding and contracting, maybe cracking. So I have to have a higher, a higher temperature plastic that can handle what I need to do. And so ABS is probably the next go-to. ABS being probably one of the hardest ones to print because of the warping and the contraction. And ASA, I'm not going to make as if I know the difference between them, but ASA is slightly better, maybe a little bit less prone to shrinkage and a little bit less prone to warp, but at the end of the day, costs a little bit more. I'm okay to pay the price so that I can just have a machine that I know will not need to be rebuilt 3 or 4 months down the road. I did order my printed parts also from a UK-based company, and unfortunately the parts that did arrive weren't really up to the standard that I wanted. And I do realize that we all have different standards, and I also do realize that you're not always going to agree on what standards should be delivered, specifically because of the way FDM printing is working, and heat conditions, and smooth beds and not smooth beds, and textured beds and things like that, and layer consistencies. So eventually I had to make the call, and probably this is why my video I started this video almost was planning to do this build almost 3-4 weeks ago. And when the parts arrived, I looked at them, I thought, I can't use these parts. And the company I use, I still think they're a good company. I don't think that there's anything wrong with the standard that they want to deliver. Maybe there were 2 or 3 or 4 parts that could have really been improved, but lots of people would be okay with that type of printer, but I'm not. My standard is a little bit higher, and so I decided I have to print all my parts by myself. That has taken quite some time because the big printer is no longer printing. It's not working. And so with a lot of time and a very small bed, I will switch to that, and I'll just point, and on there you'll see there's a Voron V0, which was a Voron V0.1 and didn't work very well, so I stripped it down totally and I rebuilt it up from scratch with ABS parts, and it's now a Voron V02R1, I think is what they say. So it's the latest changes, and it is working. But you can only print a 100 by 100, 110 by 110, and maybe 110 square, which, yeah, if you look at the size of the parts that you need to print and the volume of the parts you need to print, it takes a lot of time. But what an amazing little printer. And actually, what an amazing education to actually strip down that printer, because I bought it secondhand from a guy in Dubai, and strip it down and actually get to see the Core XY process, how this whole concept works, and actually to build up a printer of that scale before getting to the bigger printer. Now, I would say dealing with that little printer is quite different because it's very difficult to get your hands into everything, and it really challenges you in terms of finding the space to do everything. But that printer is running with a heated chamber on the side. A heated chamber. I've got a PTC heater running on the side of that thing. Yeah, I can tell you, what a machine, and the quality of the parts are amazing. So maybe what I should do is just grab a part and I can show you some of the parts really close up. Let's see if we switch to the side camera over here. We can have a look at the parts that I've got over here. So trying to focus on this might be a little bit hard. Let's see if we can get it focused. Yeah, no, that's not going to be the easiest thing to get focused on. But in any case, there you can see a bit of the layering. That's something that I wanted. I wanted a textured surface, right? And that textured surface just adds a bit of an extra nice look to it, because you're going to look at these parts quite often. And so that little printer has been pushing parts like this for 2 weeks non-stop. And yeah, pretty much there. And that's why I could start the stream today, because I'm at the point where I can actually do streams for 3 nights in a row now. And the intention is to do 3 parts, and tonight, tomorrow night, and one more night, Sunday night, and see how far we get. We're just gonna go as far as we can per night, and then we'll see if we need to book more schedules. Now, I don't suspect we'll finish this weekend, but that doesn't matter. The intention of the videos is for someone to be able to look at a later stage and actually learn from them, and that's the most important item. So yeah, I think without further ado, and I'll be talking about a lot of stuff. Apparently, when you stream, you need to be able to talk to people out there. You need to be able to watch the chat session, and I can see Evelyn, and I can see Michelle online, and I can see Michelle is actually my wife. She's 7,000 kilometers away. I'm missing my family quite a bit, and I'm really looking forward to having them back. But at the same time, it's a good opportunity for me to do these videos because there's nobody running around the house making noise. So I appreciate that I've actually got this opportunity to do this, and that we actually have enough time to finish maybe the printer before the family gets back. But I don't think that will be the end of the printing. I think there might be other sessions. You probably see in the background I do hydroponics as well. I've got some other ideas of doing some additional videos and 3D printing for hydroponics and things like that. Yeah, I'll be adventuring out there. Moritz, I can see, is online as well, doing a test there, and thanks for joining. Let's see how it goes. So earlier today, if you've ever seen the RatRig build, can I say, user manual, creation manual, you would have noticed that it's quite intensive to get everything done inside a can I say, a standard video. So there's a lot of prep work you can do before the time, and there's a lot of prep work you can do during the show. I, on the one side, decided, well, no, I would really like not to waste people's time too much. And I decided to do prep work. So Mr. Fig, that's online there, kindly helped me prior to us going live, and we did a whole lot of prep work. And I think for me, just to give you ideas to what the prep work was, and not to shortcut the steps that are needed, I'm going to switch to my screen. So let's see if I can get this without messing it up too much. We'll switch to and you should be able to see my screen. This is the RatRig official doozy page, where all the user manuals and where the configurations are, and all the different steps. And man, I'm going to tell you, there's a lot of good information here. You need to spend lots of time on these pages prior to even ordering your printer, because the more information you can get, the more informed decisions you can make, and the less wastage you'll have buying parts that you thought, well, I'd rather upgrade this to a different item. So without further ado, let's go through some of these steps. As part of the very first step, we can even go back. Let's go back one more step. On the main page, when you get into their page, you have this section called Build Guide, and inside the Build Guide, you will have different types of builds that you can do, where you can actually upgrade or change the electronics or do some add-ons and additions. In this build, we're going to do the enclosed V-Core 3.1. It is the fully enclosed printer. It's not just the standard V-Core, which you can buy without side panels and that, and you can just print, but then you don't have a chamber to heat up, and I'm interested in heating up a chamber. You can build the V-Core, the first V-Core, and then later upgrade. I just decided to do it all as one project because it would just be faster. Then going into that section, it breaks it down into different areas as you go along, and steps as you build, and you just basically follow the steps one at a time. Going into the preparations, when you print some of these parts, you will see that they have what they call sacrificial layers, and you need to break these sacrificial layers out, and there's different ways of breaking the sacrificial layers out. You can knock them out with Allen keys, or take them out with screws, or clean them up with a little bit of a blade and things like that. And that was all done by myself and Mr. Figvis today. He helped me get all of that done, because I really didn't feel that we would bore you people with looking at that. And they take you through all the different parts where they need sacrificial layers to be removed and cleaned up. The next thing that they do is they also give you a bit of a step as to say, well, you're going to build this machine, you better have some tools. And I can tell you now, you will probably use these tools predominantly, but I've also got additional tools that I use, which I've used over time and like to use. So maybe you'll see a tool that I've got. Maybe you want to drop me a message and say, okay, what did you do? Why did you buy that? And I can maybe help you with that as well. Panels. So on the side here, you will probably see the panels against the wall. Again, panels are not sold by RatRig directly. The shipping of that is too difficult for them. And I think there's a lot of risk in terms of damage to panels. So the panels, you get the CAD drawings from RatRig, and you need to take it to a local store where you can do laser cutting or water jet cutting. Typically, mostly the guys are using laser, and you then have a choice to buy it in Perspex or in acrylic. And the thickness, you pretty much have to stick to what they have, although you can build some variations. Some people build heavier printers with thicker acrylic. I went for a 4mm acrylic. I really want a little bit more insulation for the heat, and I also want the less warping because I'm going to be heating it up. You can go with a 3mm, and I don't think it would be an issue, but because I could fit the 4mm in, I've decided to go with the 4mm. And we'll discuss those panels as we go along. But I had those cut locally, and yeah, it was pretty easy to send them the files. They sent me a quote, and I had them delivered a little while later. They give also some instructions over here as to your installing of nuts and how to install the nuts. For those that are new to 3D printing, you know, we typically use hex nuts for a lot of stuff, but we also now more and more use inserts, heated inserts. So in certain places you will do heated inserts, in some places you will do the actual hex nuts, and they actually explain to you how to just pull a heated hex nut into the fitting so that it is neatly seated. So again, kudos to the guys that wrote the documentation, very good. Then we actually get to the printed parts, the parts that we need to prepare, and all of these items that are showing over here are shipped as part of the kit, depending on the size printer what you have. Now, RatRig have three different sizes on their printers: a 300, a 400, and a 500. Yes, I did go with the 500 because I want to do some much bigger prints. I've got some bigger ideas as to what I want to print in the future. And not just that, I've also purchased a 300mm plate, and maybe RatRig will look at me later on and say I'm crazy, but I'm thinking of putting the 300mm bed into the bigger frame. And the reason being is you don't always need a 500. The 500 is big. It's 1,500 watts. It's a lot of electricity consumption if you're printing very small parts the whole time. So I'm going to, once I've finished the 500 build and I've actually tested the whole thing and I'm happy that it's working, I'm actually going to build special arms inside this printer, and I'm going to make the 300 bed work. Now, will I do it as part of this series? No. I might even do it afterwards as an additional video, you know, options that I've done and builds that I've completed on my own as unofficial builds, and maybe someone will like it, and maybe someone will like to use those parts, and I will share those things, those parts that I design, most likely on printables, so that future people can also do that. So without having to bore you to put all those nuts together, because there are a lot, I'm going to just pick up two parts quickly, and I'm going to show you what it looks like to put these parts together, where we've got the corner plates, we've got T-plates, and again, just look at the documentation detail. Put screws in from the head screws from this side, the cap head screws, then push them through the inserts and put the T-nuts on the end. Don't tighten the T-nuts because we don't need them tight yet. Then they tell you to get the next set ready, and again they step for step take you through the whole process. The four corner pieces, again, they come up and they tell you where to do, what size to use where. It's all color coded. you pretty much just follow exactly what they say. And when you finished, okay, this is the other corner. When you're finished, you get to these little 90-degree corner parts, and again, they explain to you exactly what you need to get ready. So let me grab two of those parts quickly. Right, so these are the parts. Maybe what I can do for ease of viewing now, I'm going to switch to the side camera or my top cam, and we'll see how that goes. If you can see it, let's see. That's the side cam. All right, so from the top, I like that. I've learned a lot. I'll give so much credit to Nero 3D. I've watched so many of his videos, and he's got two different locations, one downstairs in his basement and one in his garage. And man, the guy's got it down to a T how to stream live, and just he's got the gift of the gab as well, which is nice. In any case, so these are the parts. There's the T-nut screws. They're the heads, the bolts that I needed to put through, and I've prepared all of these up front, right? Very easy to do. Just get them right. Get those bolts roughly loose. You can just put them a little bit through because you're going to put them into the extrusion and into the extrusions a little bit later. Same with the corner pieces. Just prep those, and then the other ones with the stops, and then the other item was the actual corner pieces that we're going to insert. So all of these pieces we're going to use over the next hour or so, and 2 hours, and use them to actually start building this printer. In the preparation area, there's one more item that they bring in, and they say, well, we should be preparing these items. Now, I didn't do the magnet preparation at this point because this magnet preparation is done used much later in the build, so I've still got time to do that, and I will then do that a little bit later, and if there's any challenges in doing it, then I will specifically come back to this document and stream actual magnet preparation. But you can see it's quite a few parts that need to be done, and it's quite boring. It took us to do these items, it took us about an hour and 20 minutes, I guess, give or take. Mr. Fig, you remember? I can recommend that when you do this, you use rubber gloves, because all the screws do have oil and grease on them, and don't wipe the oil and grease off them. That's there for a very good reason. But if you have to do this alone, I saw with other people, they spent nearly 2 hours doing preparation just on a stream, and it adds no value to the person watching. So I've done some pre-work for us. All right. Thinking now to move forward, I think the best thing for me to try and do now, and just with those that are online at the moment, I see the sound is okay. You can hear me nice and clearly. The other question that I have is the music's not too loud, and that it's not in the bother room. But it's very terrible to watch a video sometimes and there's absolute no sound at the back. So from time to time there will be music playing in the background. It's just soft classical music. There's nothing fancy about it. But it does help with the stream while I'm thinking and doing, that you don't think nothing's happening in the background. So maybe if one or two of you can just let me know how that, if the audio is too loud and I can bring it down, or if it's too soft, because that's part of the learning experience. The other thing is, you must remember that with your messages coming through, there's a delay on the YouTube stream. So if I don't respond immediately, or I respond and you don't see me actually do something for at least 5 seconds or 10 seconds, sometimes it's because you're seeing the video a little bit longer later than what I'm actually streaming it. whereas the messages are coming through to me instantly. I can see your messages instantly as long as I watch the screen from time to time. And then I've also found that even streaming from South Africa, the test last night was up to a minute delayed. So apologies if you're sending a message and we're long past it, and I'm trying to figure out. So I will try and go back. But if you send a message and saying, listen, at that step, why did you do, or you have a question at that stage, I'll try and answer it, looking back as to where we were, possibly when the question was raised. Good. So when I disappear off screen, it's because it's impossible to have everything on the table. And so just having a look, you will see all the items are lying over there, prepared behind the other camera that I'm using. And I'll be walking backwards and forth and just trying to collect those and make sure that I have as little clutter on the table as possible while I'm doing it. Yeah, let's get started. So what are the first steps? I haven't even looked at the document further today. I haven't looked at it for quite some time. So let's quickly go to the document, and we'll see that when you get to the end of your prep, you click on the button for the next part of the guide, and it takes you there. So this is essentially what we want to build, first of all, and this is just the frame. And please take your time. I'm going to be taking my time to build this, even if it takes me longer than what I anticipated. I will rather do more streams and more videos than rush this part, because the quality of your printer is very much determined by how carefully and how nicely you put this together and how accurately you put it together. And so don't rush this. Just a note that all the measurements that you will see inside the document, because there are different variations of the printer, you need to know what to build. Now the document is based on a RatRig V-Core3.1 300, meaning the 300 millimeter base plate for printing, and that's not the size of the printer. The outside dimensions are bigger, so please take that into account when you're ordering your printer. When they say 300, it means that the printing surface that you're going to be printing is 300 by 300. In my case, I went with a 500 by 500 print surface, right? Which means I need to add 200 by default to all of the measurements that they give, because this document is focused on the 300 printer by default. Just to give you indication, the 500 by 500 printer is probably in the region of close to 800 wide by nearly 900 deep. And 1 meter, almost 900 high, I think it is. I can't remember the exact dimensions. But so when you all want to order a printer, go and look at your external dimensions on the website and make sure that you understand the size of the printer that you're purchasing before you decide on the bed size. Because a lot of European houses and even some of the American guys are saying they cannot get the 500 by 500 through a door. Now, I'm lucky I've got very wide open space and I've got sliding doors, so I can get the 500 by 500 through, because I can fit a meter by a meter printer easily through a door. But not everybody can, so be very vigilant about that. And also, as we go along, just remember I'm going to be adding extra length to all the items. So the first thing that they ask us to do is actually to get these extrusions ready, and there's two 650s, two 640s, and one 620. Now you can probably see from the camera on the front, that I'm just going to switch again. Switch camera here. You can probably see that I've got these extrusions very much lined up, and let me take one of these, and I'm just going to push the bottoms together, right? It's very small difference, So when you actually measuring out your parts, make 100% sure that you've got the right ones. And yeah, I've got a 650, a 640, and a 620. And it's very important to do that. Otherwise, there's lots of different sizes and extrusions. When you finish building to a certain point, you're going to turn around and say, oops, now I've got to go back and redo a whole lot of work because I didn't use the right parts. I'm going to actually just grab some of the parts further. These corner pieces are also now needed, and we will then move to the next step, which is actually putting this together. So let me grab those quickly. One good thing is while I'm walking around you can still hear me, so otherwise this afternoon I had a cable mic and I would have had a lot of issues moving around. That wouldn't have worked. It would have been clipping mic on and off, which would have been terrible. Any guess? Let's have a look at the documentation again, and we will go back here. So the first thing we're going to do is we're going to take the longer pieces, the 650s, and we're going to place them in length. Now, let me do this while I'm about it. Why am I working on this nice green marble surface? Well, again, there's a wise guy that lives in Canada, and he does a lot of building, and he said, get yourself a piece of granite or marble stone, or not granite. I think granite has a problem because oils go into the granite and pull and it might scratch. But this is a kitchen surface top that is available. I drove to the industrial area. I walked into the first shop. I just chose anyone. I didn't even know which one I was going to go to. I said to the guy, which is the ugliest piece of countertop that you're not going to use, that you're willing to donate to me or charge me very little for, because I've got a special project and I just need a top. And he looked at me and he said, what am I building? I said, no, it's just for, I need a flat surface for building a printer. So he very kindly walked outside, went and looked at the back, and came back to me and said, come have a look. Showed me this piece. It was used previously with them for some glue that they were mixing at a client, and he says, I can remove all the glue and it's not the prettiest, but it's flat. And he cut it to me exactly to the size that I wanted, and he gave it to me for free. So I will probably do a shout out at some point to him. I can't remember what the shop's name is, but I do have his details, and I said to him, if he ever needs anything in 3D printed, I'm happy to help and return the favor at some point. But do that, because you want to build on a very flat surface. In actual fact, the surface that I'm going to be building on it's not a must, but what's nice about it is it's not going to warp as a table could. Wood would bend slightly. This won't bend. So that, number one, I'm not going to get wobbles in my equipment, in my frame that I'm printing. And the other thing is, I'm actually going to put this underneath the printer long term. Why? Because the printer's got a lot of inertia and a lot of shake. The more weighted it can be, the less movement it possibly have. Now, my table's bolted to the wall, by all means, but still there is vibrations. And I can tell you, when you get into printing, vibrations are one of the biggest things that actually cause artifacts in your print, which is terrible. You cannot believe how little vibrations that you can't see with the eye actually cause a lot of problems on your prints looking good. And so use it to put your print on. It makes sense to actually help if you can't bolt the table to the wall. I'm looking at this install one corner into each corner for and tighten screws. ensure the corner assemblies are flush, square, and ends together with afterwards. Okay. Assemble the 450 and the 440 extrusions together as shown, and make sure that the extrusion joints are square. Tighten the M612 screws to secure exterior subframe. Right, so looking at the second image, they've gone from here to here, and we are now going to slide these things. Now these are the T-nuts on side there, so basically as you turn this, it actually turns inside the channel and it actually tightens itself up against the channel. So nice concept, easy to use, and we don't have to drill anything anywhere. We just need to tighten. I'm going to start off by just trying to get this as close as possible to the corners, and then I will see how it goes. Just want to double check. Right. Put those there, and then we'll do these ones. Yes, I'm probably going to be standing a lot and bending over a lot, so something that I'm just going to try and sit and stand the whole time. Seeing as though I've had back surgery before, I need to, from time to time, try and see if I can relax the back a bit, because bending over like this will be challenging over the course of 3 hours. Okay. Some of these bolts are a little bit, can I say, tighter than what I would have thought. They turn easily, but I must say so far the quality has also been very, 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 very good. You have to see the wrapping that these items arrive in. Each one's individually wrapped. Every little plate is individually wrapped. It's really, really, really good. Okay. You will see also that we're going to tighten those corners like that. So let's do the following. Let's go to a overhead camera maybe, and that way you can see some of the work that I'm doing, although I think the overhead camera is not high enough, which I'm going to have to improve on. Let's see, can we maybe make this camera a little bit higher? Yeah, that's better. Let's see if we can do that and that. Okay, well, let's do that. Maybe we can go a little bit further and just that way we can maybe get more of it in. Thank goodness I bought stands that can actually change size. All right, well, you got most of it in. And what they did say was that the top corners over here, these ones will be going to be flush, and those corners will be together at the top. Okay. Okay, and then this one is going to be, yeah. Yes, and if you see me working with my tongue, my wife does blame me a lot. So when I'm trying to focus and get things done, I work a lot with my tongue for some other reason. So I'll try and not do it too much. Yeah. Next, what I'm going to do is put this one inside here, where they've said that we would leave it flush with the corner, and with that corner. I think I've already actually done it wrong, by the way. Yep. What's to do? It was too hasty, and was supposed to push this corner on the outside. Check, double check. Probably important. And hopefully when you're finished, you don't have too many pieces that are incorrect. That one. Alright, so this is shape-wise. I think these brackets are difficult to work with because you must know these corner pieces are pushed out on high volume. I don't think they're not machined corners. So when not being machine corners, the probability of them being incorrect is there. Let's take this one apart again. To get that there. I'm trying to space the screws out as well a little bit, the nuts, so that okay. Just double check that was right. Let's take this one. Okay. Looks fine. Let me just give it that a bit of a extra tighten. I forgot this Allen key of mine has got a problem on it. Let me just try and grab a new one here. For some other reason I need to grind down this one Allen key because the edges weren't burred properly, and so it's got this over burr on the sides, which then make it not so great in terms of trying to get it into the hex nut. It just refuses to go in. Okay, and we're going to take this one, right, and that. Basically, what I'm just trying to do is, you can see I'm moving one piece backwards and forwards. I'm not worried about tightening that one piece. I've got it roughly squared at the moment, and what I'm trying to do is take the other bolt and first get the corner piece flush with one of the extrusions. If that makes sense. So I'm pushing it up against this. I'm pushing that up against there, and making sure that that is sort of square, and then tightening that to there so that this line is straight. We're going to measure now with a square in any case, and we're going to try and get the whole base as square as possible because that's vitally important. But until I've got there, I need to see if I can just tighten that one. And this is not working, so let me just pull this one out of it. Very difficult working on such a big printer because you've got to bend so far over to actually get to anything. See if we can get it to spin around. Not rotating like I want it to rotate. Right, yeah, it's rotated now. Right, that's better. Okay. Yeah, that's better. Right. Now, what I'm going to do is I'm actually going to use squares to actually bring these things together. And you don't have to use these. You can use just a standard square like that. I've got these. I want to see if they're going to make my life a little bit easier or a little bit more complicated. I'm not quite sure yet. We'll see how it goes. With the parts being where they are, it might just be harder, but let's see. Let's get that one tightened onto that extrusion. Right. Look, why is that corner not the same as that? Maybe I need to let's go back and loosen this one slightly again. Okay. Let's see if that does the trick. There we go. Put that over there. Okay. Probably not tighten them too much. Pull the screw. Out. This one. As I say, this is not the easiest part of the job, but take your time to do this. This is it takes a little while to get it done, and you need to double check your work quite often. Just make sure you've got it right, because if this frame starts off skew, everything from that point onward is going to be a challenge. Okay, let's leave that like that for a moment. You can see building this frame even on this piece of block is going to be a challenge, as even this block is not going to say 100% big enough. Let me just quickly switch off this other printer here. Yes, finished printing some of the parts which we're going to use tomorrow, and it's now got to cool down. Okay. Let's Let's take this thing. Would have been actually nice to have had this in the inside, but because you've got the inside corner here, you can't. It makes it easier to work with all the different types of screws, but it's fine. We're gonna do it once. We're gonna check it twice. We're gonna keep measuring as we go along, just to see what we as close as possible. All right, let's have a look. If we tighten this one a bit. I once watched a guy doing this on a video live as well, and after like 45 minutes, he like, maybe I'll get back to you guys, because he just couldn't get that frame to work properly, and he knew that if we didn't get that frame right, that doing anything from that pointing forward didn't make sense. And it was good that he actually stopped the stream. He said, right, I'm going to go and sit down and figure this thing out properly, and tomorrow I'll come back to you guys and just show you what I did to make it right work. And he stopped his whole build, which could happen. Which could happen. Where are we now? 7 o'clock. Goodness, doesn't feel like, feels like 10 minutes have passed. Yet it's almost been an hour. Right. So let's take these off here now. These are super nice parts. American engineered. I'm not American, but these are American engineered parts, and I can tell you now, super nice. I actually want to bring one of these extrusions in here. I don't know if I'm gonna make my life complicated like that, but let's see. Drop that one there. Drop that one there. Push that all together. Slightly tighten that one. There we go. Probably not a bad idea doing it that way, because I can now at least loosen that one again. Just double check it. Let's loosen it again. Yeah, I've tightened and loosened some of these now 2 or 3 times. I think the problem is the bolts that go through here can move backwards and forwards, and the bracket can move backwards and forwards. So you've got to be careful that you don't put the bolts in such a way that you can't get to them in the future. I would have liked to have seen maybe that they just made holes and not grooves for it to move in and out, but I can probably there's some logic around the way they've done it, which I'm just not seeing. Long Allen keys. If you can get long Allen keys, get long Allen keys. Long Allen keys make a big difference. I want to say the longer you can, the better, but I think there also be limits to how long actually means, and when it becomes a problem itself as well. But at this point, much nicer working with a longer Allen key. And if you can, if you have a look at the Allen key, it's got this little bob on the end. I wonder if I can get that focused sort of like that. That helps you actually, you know, you can get some flexibility and corner in there. So don't whereas this Allen key has a straight edge, this one can stand at an angle like this and still tighten. So get yourself a set of Allen keys where you've got that ability to tighten at a slight angle. It makes a big difference. Thought maybe I should look at the chats because I forgot to look at the chats. You know, I'm not used to that. Thank goodness I've had like 2 weeks to 2 weeks home alone, so I've got quite used to talking to myself here. So while I am talking to everybody else watching and those that will be watching in the future, yeah, talking the whole time. Didn't think I was going to do that this summer in the UAE. It's hot outside. Humidity's been terrible for a couple of days, for weeks now. So you stay indoors quite a bit with can I say, the possibility of talking to yourself a lot. Okay, I think yeah, I'm also going to take another extrusion and put it up vertically because it will just help get it in. Let's get this one laid up right. Yeah, as you can see, these brackets that I've got, and you don't have to buy them from international. They're available in different brands in different markets. I just like this brand specifically because I've dealt with it before. Actually, a friend of mine introduced me to these, and once I saw the quality, I was sold on. This is the only product that I ever want. Okay, let's do that and that. It's going to be interesting when I release this how it's square it's going to be. I'm wondering at this point in time. This one I put too deep. So let me just show you what I say when it's difficult to work with the slots. Maybe you just know when you're building a printer like this. You can see inside the slot the nut can move backwards and forwards along this. So when you push both nuts into the corner, you have a problem, but you can't actually. I can't show you now. Maybe I'll turn the light slightly. You can't get to the second nut because it's in the way. So you've got to try and make sure your nuts and your bolts are as far apart as possible when doing this as well. It's also better for the strength of the corner the further the nuts are apart, the bolts are apart, because it actually pushes the extrusion with more angle into the bracket. Like this one now is unfortunately this one has now gone and moved right up into the corner, which is not what I want. Right. No, that's not good. In other words, I didn't tighten it enough. That's moving. I don't want that to move. So let's do that one more time until we get it right. goodness gracious, can you? Okay. By using these corner brackets, it is a little bit more challenging actually for me to get to the actual Allen, the bolts with the Allen key, which, as I said, slightly longer would have been nicer. Too long will probably be a problem later on. Interesting, quite easy to set up OBS and stream, I must say. I thought it was going to be a much bigger process and much harder. Yeah. So it's got 3 cameras and then integrating a stream deck into it. Okay, so I borrowed the stream deck from our chest because we're not using it at the moment, just to see how it works. But I'm actually glad I did borrow it because it actually does make switching so much easier. You know, I've got all these views set up and I can just switch between them. So going to this camera, I can have the camera on its own, and I just push another button, and I've got this camera with the top corner, so you can see that I'm not hiding, and move back to the main camera. So yeah, it really makes life a lot easier. And you can put slides up, and you can switch to your presentations easy, your Google, your browsers and stuff like that. It just makes life a little bit easier. Okay, so I'm now taking these off, and I'm going to do my initial check to see how much of a square have I managed to be able to create. And so first of all, I'm going to just do a check with this. Okay. They've actually got a nicer another method of doing this as well. So we'll see now the method that they recommend. There I can see it's probably not as square as what it should be. Let's go to this corner. Yeah, not bad at all. Again, these extrusions are mass produced, so are we going to get them 100%? I don't think so. If we go back to the actual document, let's see if we can get back to the document. No, you can see the document. They're going to tell you to tighten those ones first, and then push that together, right? And then now we're going to try and measure and make sure that that distance over there of that one is equal before we proceed. But before I tighten this middle one, I want to check this frame is square, and so this is the way that they check it. You measure pretty much the diagonals, and if the diagonals are equal, then you've succeeded. If the diagonals are not equal, then you've got a problem. And they actually even give you the dimensions that you should be trying to achieve, which is in my case 933.5. So a little bit nervous to actually check if it's actually that measurement, but you know, got to be done. So let's have a look. I'm going to go with a steel ruler for this one, because I just feel it's going to give me a better ability to check. I'm going to, how am I going to make sure that's square? Let's do that. Let's do it like that. So 9, 1, 2, 3. This line 3.5. Might even have it there. Might be right. We'll get that back. I need something a little bit thicker. Maybe I should use this one. Maybe this one will work a bit better. Yeah, I can get that. Yeah. And then I can get that thing on that corner. One, 2, 3. You could argue that's a 0.25 or a 0.5. We can probably argue that. Yeah. Let me just see if it's easier to measure with the other tape measure. What I'm going to do is, let me switch back to the overhead camera, and at least you can see what I'm doing a little bit better. Actually want to move this camera slightly this way. Okay. So let's take that. .933.5. Let's see if we're clear doing this way. .933.5. Guess you call that success. Okay. That's not bad. Not bad, not bad. First try. I didn't expect to get it on the first try, but yeah. Just gonna do another double check with this ruler. I've got OCD. I like to have double check everything I do. No, I don't have OCD, but I just like to be very precise. Yeah, that's look. If I have to measure it anymore, I'm gonna drive myself crazy. But that's pretty square. That's nice. Again, I think testament to these brackets helping a lot. A little bit harder to hold this like this and actually do the leveling like this, but it is totally possible. You know, you can. It's just a lot more hands. You know, you need to hold this and hold that and push this, and so there's a lot of components in there to hold. Okay, let's go to the middle piece. If we go back to what they were asking us to look at, so go back to this over here. We want to make sure that the middle line is in the center, so our outer edges are the same. We should ideally be checking that that's square and that one is square as well, that the top is square and the bottom square, because measuring over here in the middle doesn't necessarily make sure you're going to get it right on the ends. So the one option is actually to do measurements that side and that side, but I think this is not critical that it has to be perfect. It just needs to be squarish, and it helps for getting it in place for later on because it's more structural than what it's dimensional. So we're going to measure those two. We're going to get it roughly in place, and then we're going to use these corner pieces again, I guess, to make sure. that we've got this plate in place. So let's do that, because we sort of got an idea that everything is square. Okay. Yeah, that's going to work the easiest. And then I just take into account you've always got this measurement, this and I'm just going to switch over to the top cam overhead again. Now I can't see what you can see, so I've got to switch over myself. Just take into account that on the top of your head, this piece moves backwards and forwards. So if you're holding it and you're pulling it, and then you're turning it around and you're pushing it, your dimensions will be this different. So you either got to push and push, that it's the same, or you got to pull and pull. Okay. I'm going to push it against, and yeah, we've got 32.5. Yeah, we've got 31.5. So I'm about 5 mils off. I'm going to push that over to there. Push that over to there. Okay. So we've got 32 on there. Oh, silly. Yeah, I'm doing the same mistake again. I'm going to do the measurements from the outside. That's 32. And that is all the way. 32 is there. So we're going to move it. If 32 and 32 is the same place, we need to move this all the way across. Maybe Mr. Fig will like to join me tomorrow night in building some of this. We'll see what he does. He doesn't have to sit out there and watch me the whole night. Elven Mighty Thunder. That name, now I recognize the Elven Mighty Thunder. That's a very famous little girl that does Star Stables, and she's got her own YouTube channel. She produces quite a few little videos. And she's got quite a few followers as well, I see. So there is a bit of competition in the family. I'm going to have to make sure that I step up my game over here and make sure that I also get some followers with time. Yeah. So that little girl's my daughter. She's she's not little anymore, to be honest. So she's now hitting ages which I think scare me a little bit. But she's super cool kid, and love it, love it. But 30.36. 36. Okay. $35. Okay, I think I've got it right. Question is now, do I just knock this? According to this thing, that's straight. Let's just pull that up slightly. Let's check that again. 31. Okay, I think that one's in the middle there. So what I'm going to do is actually just start on this corner and tighten the bracket in a bit. Then I'm going to have a look at the other side and see what that's doing. I won't tighten it too much now. I'll just get roughly right. Hey, Mr. Robert. Another keen 3D printer enthusiast living here in Abu Dhabi. Welcome to the stream. Thank you for joining. Trying my best, you know. Hopefully we impress enough people to get some more followers for tomorrow's stream, or the next stream when I try and do hydroponics. So Mr. Robert, he's also into hydroponics. Just started out there as well, and I think we've both got ambitions of using our printers to gain functionality for the hydroponics build stuff. And I think also Moritz, the Yannickas that are there, they're also keen hydroponic people. So we're going to see what we can print in the next coming months that helps us build better hydroponic stations or concepts or whatever we want to call it at this point. Oh, yes. Robert, you should come and join me. Build this printer, and then you can strip yours down again and rebuild it with all the rails that I've got lying around here, man. Wouldn't that be cool? And you can upgrade your own. You can upgrade your own printer. Looks like I've just moved this whole thing. Let me see. Oh, no, I didn't. You know. A lot of measuring, guys. A lot of measuring. Measure once, measure twice, measure 100 times if you have to. Just make sure you measure. Let's see. Push that like that. Push that like that. Double check this one again. And every time you tighten a bolt, you have the slight possibility of a little bit of movement that goes out, like this one now. It's just moved out like 0.5 millimeter. But in this case, I don't think it really makes a difference on this part of the printer. That one's still nice. Spray. Let's see if I doubt it, but I've got another printer enthusiast down the road here. He needs to start looking at buying himself a resin printer. So that's the other side of printing is instead of you doing FDM printing, what filament deposition modeling, uh, uh, you can do resin printing, which is also very nice. It gets super cool for small models, models with details. And the guys that build, can I say, little model aircrafts or miniature characters, or that's where those products shine out. The resin printer really gives you that fine detail. So when you're looking for a printer, you need to also have a look and say, you know what, is it a resin printer I'm looking for, or is it a filament deposition FDM printer? The big difference over there is the details and the size. So you need to go big. Well, you can't go resin, because resin is just to a certain point. You can probably print, I think some of the resin printers are probably about, I think 200. No, lie. 150 wide by like 100. I can't remember exactly sizes, but I can tell you now, there's a big difference. You can't print very big at all, but you can print super cool, and that will be something I will do in the future. But I would do it based on the fact that I would need someone to have a requirement for me to print first for that. I'm actually talking to I was there a little while ago, a company in Abu Dhabi. They do board games, and the board games people are obviously into their characters. And let me tell you, board games are big still. There's a lot of people doing board games, but serious board games, not monopolies. I'm talking about serious games, and they got strategy and they print. And one of the guys that I know that should be buying the resin printer, he actually printed mugs for a competition, so that each person would have their, I want to call it warlock mug or something like that. And that was quite a big job, and he actually had to print it and paint it, and it took him forever to do. But man, until if the shop knows what he did, he'd probably be busy doing that all the time. Although I don't see him wanting to do that all the time, because it's really not the nicest job, painting things the whole day. We're still spot on, guys. So that's really good. Yeah. So you sit down for 1 minute, switch back to the main camera. We've basically constructed one section. Now, big benefit of building on the surface is if you push down, do you have wobble? And there's no wobble, meaning at least while I've got it dimensionally accurate this way, I've also haven't got any twist in the frame. That's just as important, and hence why I'm not doing it on a wooden table, because I can tell you now, if I sit or push down on this table, it will deform slightly, which is a problem. Okay, now I'm just going to think what to do next. Go back to Chrome and have a look at the document. Did I miss anything? Double check. Right. We've done these measurements. If the measurements are not equal, you are not close to the shown above. Double check all the corners and square and check again. I can't emphasize how important that is. You see guys build their printer and then they eventually just can't get it right and they give up. Next portion is creating, assembling the electronics subframe. So we've got to take 4 of these 90-degree corners and we're going to put them in there, and we're going to put them flush with that. Okay, now ensure that corner assemblies are flush and square with the ends of the extrusion after tightening the screws. Set this assembly aside until, so once we finish with this, we are actually going to move this whole frame to the side, and yeah, exciting. This is the electronics panel. So maybe what I should do is give me a second and I will go back to this page, and I'll just show you how cool this website can be. Let's open this one. Mr. Fig said I should show this, so I shall honor what he asked me to do. Okay, and not design, no. We want to look at documents, no. So I just got to find where model browser, that's what I'm looking for. And we're going to expand this model browser a little bit. And so here's the RatRig printer that we're looking at, and you can see the different components here. Now, what we just built is, let's do the following. Let's switch this off. I can take a breather with my back as well, bending over that table the whole time. Nearly there. You can see I've been here before, sort of know where to go and sort of what to look for. Want to switch off that, and that. Okay, so here's the frame. If you look inside there, there's a frame at the back here, right? There's the middle piece. We just built the back end of that printer's frame. So that's the inside of that frame for now, where the electronics panel will be attached to. The electronics comes on the back here. And once we finish with that, then we can put that aside and we're going to move on to the next model, next portion of the frame, which would probably be the outside and building the frames and the roof and all that type of stuff. If you ever come here and you want to have a look specifically at certain items, let's say you wanted to have a look at how this gets composed, you can do the following. You can blow this up, right? Very cool. Go inside there, and there you can actually see the screws and the components and everything and how it gets put together. Let's move it slightly. Oh goodness, I wanted to move it like that. That's what I want to do. You can just zoom and then you can see how all the parts come together. A really nice website, built on Fusion, and you can then download this and you can modify it as well. Okay, let's do those last couple of items now, which were those 90-degree corners, and then we can put this frame aside. Let's have a look back here. Right. 1, 2, how many did I need? Can't remember how many I needed. 4? Yeah, it was 4. Let me just double check myself. Yeah, 4 of these. And we're now going to put them onto those corners there. Right. And okay. Okay, so back to where you are. Well, let's do the overhead camera. This probably makes more sense for you to be able to see what's going on. Helps a bit. And we're going to put one here. And we're going to put another one in that corner like that. And then we need to go back and put one there like that. And so the other thing that I didn't mention is the RatRig is a 30 by 30 extrusion frame. So it's a much beefier, bulkier frame, much heavier, right, than the other printers on the market at the moment. Actually, I'm not sure if there is any other printer that uses the 30-30 extrusion. I can't think of another one. But RatRig decided they wanted the extra mass and the extra strength, and so they decided to go with this model. And I can tell you, I think it's an awesome decision, because I like the fact that it's, this thing's strong and it's not going anywhere. Let's put this. Let's move that way like that as well. So I want to get it in the middle. You know what? I know they said we need to do this up front and put these bolts in, but I'm going to. Oh no, that's not going to work in any case, because it's got little cleats to try and help keep it in the channel. So I must stay away from. Can't use the full surface of the bracket to actually center it. Oh, it's fine. Do it differently. Yeah. Okay. This is not a straightforward pinch, move and close, because as you tighten it, you're going to move some of the bracket. Maybe a better way of doing this is to actually take an extrusion, put it in there, hold it in the right place. Yeah, you see? Many ways to skin a cat. What's the saying? Best saying, I think. But beast. It depends what I want to do. Okay, so there, that one's nice and straight now. Yeah, that I like a lot more. Okay. Same with this one. So turn this one in the right way. So other thing, as I was talking earlier about, is patience to build one of these things. If building things like this isn't something you enjoy doing, then don't go with one of these self-build printers. Yes, it is nice to do it for some people, but some people just don't have the patience to do it. And if that's you, rather go for a Bambu Lab printer. Friend down the road has just bought himself a Bambu Lab. He doesn't want to tinker. He doesn't want to get the thing. He just wants to take it out of the box, print. I fully understand, fully agree that if it's not your thing, don't do it, because you can't rush this. I mean, that's why I can't say to you how many sessions it's going to take me to build this. It's going to take me as long as it takes me to build it, and that's just the way it is. The Bambu Lab is with what they call the X1 Carbon. Well, there's like 4 models now. The X1 Carbon is with the AMS is just amazing. So AMS is a automatic management system which allows you to print multicolors. So it can hold multiple different colors in the system, and you can select which colors to print. And you can print multicolors, which is really nice. It's one of the best AMS systems out there at the moment. And the guys that actually designed the Bambu Lab printer are guys from DJI, guys that build the DJI drones. They are really done a good job. And then as a company, there's a lot of changes that they need to do to get into the market. But also, with it's a new company, you're going to make mistakes. And so far, the feedback is, even though they've made some mistakes, they're fixing their stuff very quickly, and they've turned the whole market upside down. They've actually turned it into a situation where so many guys have had to do something to actually catch up, because that is like the first print of its kind in the market, and they've just done everything right. They've made it almost like, you buy an HP printer and you go home and you just plug it in and you install the software and print. Well, that's pretty much what they've done. That was their goal, and that's what's been needed in the market for a long time. Yeah, there's a lot of other things that aren't so great. They didn't do everything right, but slowly but surely they've apologized, they've fixed, or said, you know what, we're not going to be the first people to hide that we're not perfect. So yeah, I really appreciate the fact how they've actually dealt with the whole deployment and what they've done in the market. Creality obviously came back with the K1, Creality K1. Now the Creality K1 is it's a very good printer as well, but it's still lacking the support, and as much as what you buy a product, you also want to buy support. And so that's where, if you think about number one support worldwide, I still think, in my opinion, Prusa are the number one over there. But they're out of the market a little bit with their printer. They've just released the new MK4, and it's not the best. It's nothing new. Nothing fancy about it. Yeah, there are improvements, but it's nothing fancy yet. It's not a Bambu Lab. It's not a Creality K1. So, anyways, right. So there we have just the panel for the instrumentation. To give you an idea, it's big. But we're done with that. And so as per book, I'm going to now put it aside. Right. And next item that we'll go to, let's go back to the manual. And we're now going to prepare the next frame. Now this is slightly different because we're still going to start using these corner pieces. Remember, this numbers over here are based on the 300 by 300 printer, so I need to add an extra 200 to it. So in theory, I should find 4 pieces of 960. I'm actually going to try and bring my side cam a little bit closer. You can see just if I switch to the side cam, what let's see if we can do that. Switch back. Just some of the packaging. I want to show you how well it's packaged. And let's go to the side cam. Right. So you can see some of the extrusions, and this came in 2 separate boxes. Not too much. The linear rods were slidden into this thing. These things are super packed. Right, they are. Each one is wrapped individually, right, so that they don't scratch during transport and don't move. And you can't move it. It's so tightly packed, so there's no movement on. There's no ways it's gonna break. And you can see probably these are the ones I'm going to use now. That these 3 are protected from this one in that sense. So it was packed in there. You'll see on the box there's a bit of oil that came through. That was on the linear rails, which is up, which I've now packed to the side, and those rails come so well oiled that yeah, there's no ways they can rust. Again, do not wash off any oils unnecessarily, because a lot of the oils are there for good reason. If there is something where I think we need to clean, I will let you know as we go along. So I'm looking for the 960. I'll take my measuring tape. Let's see. 960. Right, and I need 4 of those. So let's take this plastic off. Don't worry, I'm not scratching, I'm just touching it lightly, just cutting through the top layer. Inside the groove. I'm actually not getting to the bottom of the actual extrusion. So I'm not scratching it. Very nice. As I said, it's individually wrapped. So that one is wrapped. That one's wrapped separately again. Let's see. Just want to reply here. People are waiting for me to answer them and tell them I'm on the stream at the moment. Okay. Nothing there. You know, the life goes on. Life doesn't stand still while you're building a printer, so you still got to quickly check all your stuff and yeah. Okay. No fires yet. Won't be any. It's all good. So let's take these extrusions off out of these plastics. I did have an argument. Well, I thought, well, not an argument, but an argument in my head that, you know, why do they use so much plastic? It is unfortunate, but to protect the stuff, I think it's the only way they can do it. There's no other stuff that they can use to protect these extrusions that way. So it is what it is for them to ship internationally. And if the product arrives here incorrectly, you don't talk to the courier, nothing with RatRig. You actually send RatRig a message and you send them the photos. You've got 10 days to actually go through everything. And if you have any problems, they will sort out and they ensure the packages all the way to your doorstep, which is really amazing. let's have a look. We need those corner pieces, 16 of the corner pieces, and then we're going to start putting those together. Okay. Right. So I've had a look at the picture. Maybe I'll just show you what I'm looking at. Okay, so it's those extrusions, those corners, and we're going to put that on there. All right, we'll put them on the side, and what they're trying to say to us is you're going to tighten those screws down the bottom, but please make sure while you're tightening it that it's flush on the ground and also meets the end of the extrusion. And then the next step will be putting the other corner on from the bottom, tightens like that, and it will look like that. Just want to go into this one a little bit tighter. You can see there's this little corner piece open here. That's important that you get that right. All right. So let's go back to maybe the front cam for a little while I get everything ready. Let's do this piece for piece, because otherwise we're going to have too many pieces open on the table. Let's put those there. Oh, okay. So again, I'm going to use this surface because it works, and I'm going to push that into there. What's nice now is I can actually bring it to the edge here, and tighten it. Let's see if I go for the overhead, am I going to throw you out totally? You can't see too much on the overhead. Sorry about that. Maybe what we'll do, let's do a different view. Let's do that. Right. Maybe we can do it like that. Right. Nice. At least you can see a little bit more about what I'm doing. All right. So I want to make sure it's flat there, but I also want to make sure that it's flat against that corner. So I can use that, and then you can see that's lined up there, and at the back also lined up nicely. So let's put that there for now. Move that way. Actually, it's going to be easier to just hold this thing like that. There we go. And then we're going to just don't tighten them all too tight. Just go one at a time, because as you start pulling the one tight, the other might move a little bit. If you try and force it, but if you get all a little bit tight and then just do a little bit tight and a little bit tight on each one, then they sort of help each other keep the whole thing straight. So by pulling the end one, this one now has also become a little bit more loose. What's the time? We've got about an hour left max. And we're going to call it a day, because I don't want to push the streams longer than 3 hours. 3 hours is a lot of time, but you've got to make sure you're doing it right. So it's fine like that. Let me give it a bit good tighten on each one. Not so nice and turned. Okay, let's flip this around this way, and I will do it from the other side. You can see, let's take your nuts and turn them all right, chuck them into the grooves, and then when you spin the nut, basically it twists inside the channel and it turns. So I'll show you now what I mean by that. Back a little bit. Okay, more of it tightened a bit more before I make it really tight. That. You can see the quality of these parts look really awesome. Well, I can see it. Don't know if you can see it, but I can. Right, there's that piece done. Okay. Just as a to show you what's happening, I'll turn this way, and we'll look at that nut. So you need to imagine that nut is sitting in that channel, right? It first goes in like that, right? So it's sitting in the channel. What it needs to do is it needs to turn like that 90 degrees before it pulls tight in the channel. So what happens is when you're taking the bolt, right, your Allen key, and you're pushing it in, and you push it in and you spin, you spin the Allen key, it turns like that, and then it wedges itself between the two of the extrusions. It sits at a slight little angle like that, and then because it's now can't turn any further, it now starts pulling tighter and tighter and tighter, and it's pulled it tight. So that's pretty much what it's doing when you do that. That's why you've got to keep these things loose so that you can get inside the channel, inside this groove, and then turn only. Otherwise, it doesn't twist correctly inside the channel. Right. So that was one. I'm going to double check. I think I need to do two. I'm going to do both steps at one time on this because it's just easier. I'm going to do 4 of those, and I'm going to do 4 of those, and I'm going to have to do 4 of those in any case. Okay, so before, I'm not going to do them separately like that. I'm just going to keep going with putting these corners on. So I'm going to do that now. Let's do it this way. Right, let me get some more. No, that's not going to work. Let me get some more of these. Bring a couple across. We're going to use most of these. All right, so I need to put the next one onto that corner. Like, that's it. I need to get it onto this corner, yeah, like that. And it's got to be in that corner like that. So we've got to get that thing like perfectly lined up like that. And on that corner there as well, and flush with that. That's interesting. There's no good, I can't think of a good way of using a tool to actually keep it square on that side. I can keep it square on this side, but then I can't really determine how much flush it's there. Okay, hold on. Maybe I'll just take one of these and put that like that. Put that like that. You see? Flush. Maybe I'll just turn it this way, so you can see what I'm doing. I don't know. Like that. So I'm pushing against this side so that I can push against the extrusion. I'm using this to keep my spacing right between the bottom. I'm using like so. In theory, I think I'm in the right place. Okay, I think it's right. You see I spin it fast there in the beginning. No, let's get there. So maybe while I'm busy with this, I can talk about my challenge with the extrusions. You know, I told you in the beginning I had to reprint everything. There are many guys out there printing parts for people that are building a printer. Okay, and some of them are horribly expensive, and some are reasonably priced. Again, you try and find one that you're comfortable with. I thought I found one that I'm comfortable with. He doesn't just do RatRig, he does the three big, can I say, the three bigger printers that I know of, which are RatRig, Voron, and VZBot. And he prints fittings for those. So he's no Mickey Mouse to this industry. He knows what he's doing. But I think, you know, too much of a rush to get something done, and I'm not going to shame him in any way, because I don't think his intention was to deliver a bad job. And in testament to what happened, he immediately refunded me the money. He refunded me fully. Obviously, shipping costs. That's the risk of ordering internationally. Your shipping costs, you lose that money. It's just part of the deal, and that's part of the risk of doing what we do. But he refunded me, but just didn't got it over and done with. He said because even if he reprints it, he doesn't know if I'm ever going to be, can I say, happy with the quality. Oh my goodness, this is not easy. Well, I'm trying to make sure I don't hash this up. You actually need like one extra set of hands to hold everything. Yeah, so just sorry, I was thinking, just making sure I'm getting it right. I've seen some of the prints he's done on the web, and he's done some great job. So when you order this printer, not everybody has printers like I have at home, right? Or the facility to print. So you've got to make a decision as to who you're going to have print your parts for you. If you can source it locally, if you can get someone locally that's got the ability to print it, please do it. Because at least you can interact, and it's just cheaper that way because you don't have to worry about shipping costs. But that's not always possible. So there's many guys out there. There's private guys doing it, and there's also businesses that do it. And yeah, the risk is there. But at the end of the day, I wanted certain quality. I wasn't willing to compromise on my quality. So that little Voron V0 has been printing non-stop. Like, you cannot believe it. It has been printing all day, every day, for the last 2 weeks. And again, testament to that Voron. I'm not going to shoot down a Voron or say which one's better. That's for everybody's own decision. I think I like the little Voron V0 because it gives me the ability to do some quick prints in a heater chamber, which I think is awesome. And it saved me in this case. Yeah, and if you can print your own parts and you're comfortable to print your own parts, remember you're going to need a heated chamber if you're going to print ABS and ASA. You're going to need at least 55, 60 degrees inside the chamber. Some people say 50 is fine. I found that I still had issues at 50. Didn't want to do it. Oh, and the other thing that I need to learn quite quickly was the wonders of hairspray. You won't believe how much hairspray helps. I tried specific 3D printer glues. I tried actually Alma's normal glue that you use to stick papers together. That worked wonders on a lot of the prints, but it just leaves this thick residue, which was worse. I didn't quite enjoy it. I thought I was going to go to this other product. I won't mention the name as well because I'm not here to shoot down a product, but it didn't work as well as what I was hoping it, and then it also had a release and there. But then hairspray, and I went into the shop. I actually went upstairs and took hairspray from upstairs, and the first hairspray I took from upstairs, my goodness, nearly gassed me out when I sprayed it. I mean, you can't believe you women have to use some of that hairspray. There's hairsprays out there with far less potent, I say, fumes coming out of it. You should look around. You don't need to use a toxic fume hairsprays, but I get it. They can't all smell. They can't take the smell away totally. There are some hairsprays that are preferred by the printer community, unscented sprays, which are available in other countries, typically not here again. But I found a hairspray. It's called Gatsby. Don't know what it is. Got this lemon scent, so it's not as if I want to run away. And yeah, everything sticks so far. It really sticks well. And what's also important is if you print on a bed that does stick well, and you cool down, sometimes you can't get the print off the bed. So the print, the printer needs to also be able to release the print when it's finished, and that's what the hairspray also does. It acts as a releasing compound, and that really is important as well. It's nice, and then you just let the printer cool down, let the track, when you're listening and you hear these cracking sounds. It's not cracking, it's the actual print coming loose off the printer bed, and it just pops off by itself. It comes loose brilliantly. So that's something else, read up about hairspray. Yeah. Mr. Terence, I see you online as well. Welcome. I won't say that I've spoken too much about you, but yeah, you're just as much of a enthusiast for printing, but as I mentioned to people earlier, I think you're the person that wants to do the resin printing. So I'm hoping soon you will buy a resin printer. Yeah, and torque. There's a suggested torque setting of about 3 to 5 newtons, but because we're working with this very bulky extrusions, 30-30 extrusions, and because I'm using an M6 nut, I haven't really seen anybody do torquing on the nuts. They don't really say it in the manual, so. But I think the guys were talking about a 3 Newton meter torque, which is pretty tight as far as I know. The percussion set squares you're using, Ray, where did you get them? They look excellent. Do they come with a set? So just these ones come from there's a company called Woodpeckers. Yeah, there you go. Right, you can go Google them. They're American based, and you can get them on Amazons as well. And there's different sizes. There's also different brands. You don't have to go with Woodpeckers, but their quality, Woodpeckers' quality, is just like amazing. And they guarantee their precision to a certain nth of a degree, which is, you can go read up the documentation. It's amazing. And if you have any problems, you can send your stuff back. And you look at this set square. It's really a good quality. And this is the smaller one. I was using a bigger one earlier on from a friend, and it might be a bit big for general, but for this printer it would have actually been nice. But in any case, I decided just to go with a bit smaller one. But these products are just really nice to work with. Highly recommended you buy. If you're going to buy a printer, buy a very good set of set squares. Hairspray works very well. Yeah, I agree. Just the right amount as well. Yeah, if you spray too much hairspray onto the surface, you have this like residue, this white residue that works. And so I found that the hairspray that was upstairs, I can't remember what brand it was, Alceve or something like that. I can't remember. I'm not a hairspray person. You've hardly got hair. If you spray too much, it made like a residue. Whereas this one that I've got now, it's a local brand. I found it in the little supermarket over here, and it doesn't smell when it's hot, and it actually sticks like crazy. And you really cannot believe the amount of stick that it has. Wow. Yeah, you're right. The ladies did see me standing there I read every single bottle. There were probably about 15 different ones to choose from. And yeah, I'm standing looking at these hairsprays, and I'm like analyzing them, and I'm reading the stats on the back of them, and I think the ladies are thinking, what is this guy doing? But there's so much technology in the hairspray as well that I've been reading up. Certain hairsprays have a compound in them that actually, when the compound gets disturbed, in other words, it has a lateral force on it, the compound breaks down totally, and they actually make the hairspray soften. So whereas the extra strongholds, the compound is not that can say breakable, which is quite amazing. And then also there's other stuff that I was reading up about the hairspray in terms of oils. One has oil and one does not have oil. Now, typically you don't want to use a hairspray that's got oil in. That's not what we want to achieve here. So I guess it's a matter of just trying different ones, see what it looks like. Oh, you haven't got the best picture, but at least you're sort of getting to see what I'm doing. You can still see me in the corner at least. I see you use Gatsby as well, Robert. Yeah, it's definitely works, and it's also not the most expensive one. But I took the level 7, unbreakable hold. Well, yeah, it's pretty much unbreakable. Yeah, what's it? Ultra hold level what? Level 7. So just got to make sure that our maid doesn't take my hairspray upstairs every now and again, or when the family's back, that they don't steal my hairspray. Got to be clear. Got to keep my eye out for that one as well. White knuckles. So about 3 white knuckles. Yeah, it depends on whose hands you got, eh? Probably not mine hands, because I'll be honest with you. In nursery school, when I was the youngest, in my youngest days, still, I was in trouble quite often. Why? Because I had very strong hands, and in nursery school, the teachers used to come and used to close the taps so us young little kids couldn't play with the water. And Raymond would come and open up the taps. And as much as what they tried to close those taps, they failed. I kept beating them by having to open up the taps. So I've got this tendency to actually strip nuts, not just small ones like this. I went and helped a guy in South Africa once with his alpha spider. He wanted to change the wheel and he was battling to turn the nut. So I said, okay, well, would you like me to try? He said, yeah, go ahead. And I ripped the whole bolt off the wheel. Ripped and just twisted the whole thing off. Okay, it's not my fault it was rusted. Doesn't make me strong. It just made the bolt weak. But at that point, I realized, you know what? Be careful. Your hands are probably a little bit stronger than what you think. Take it easy. I did not replace the bolt on the Alpha Spider. I didn't. I was still in my young days, in student days, so didn't have money for that. He drove it to the nearest garage, and they somehow pulled the bolt out and replaced it with a new bolt. Didn't even know you could do that at that stage. But I'm not playing with these, Terry. I am tightening them quite tight, because this printer has a lot of backwards and forward movement. It's got a lot of inertia in it, because it's a big head. It moves. Where are we? We're half past. We still got some time. Another 30 minutes, and then I'm going to call it a day. So maybe I can at least get these arms done. I think you've seen enough of that. We can just get back here a little while. You move these calipers out of the way and grab some more corner pieces. I must say it's quite satisfying to see the pieces disappearing slowly. That means ultimately there is progress being made. So Terry, did you take that traffic light just in time? It looked like it. One of those fancy photographs that they send you. I don't think you want to subscribe to any of those today. Mr. Fig and I were arriving behind you. We were on our way to Yasmore. I had to go and buy a microphone. The little microphone that's now hanging off my chest here was not here this afternoon. I was actually going to sit with a cable and try and use a wired mic, but sure. Can you imagine with me walking around that much, how much of an issue that would have been? And that wouldn't have gone down well. It would have been a pain because I would have had to disconnect the mic, put on the table, then come back and then clip it back, and that would have just been a mess. So I'm actually glad. I think Mr. Fig said that the mic sounds pretty clear. So I'm happy with that. I had to skip the line. Don't worry. I don't. If you went through, then I was right behind you. So you must deduct that I was close to be able to see that. I'm getting better at this. A little bit faster. A little bit harder. Oh my goodness! Here we have the wife's cat is here, and now trying to hide in the boxes. He's normally an upstairs cat, but recently he's learned to come downstairs. Okay. You'll probably see a cat join us on the table any moment. I can't see that he's going to sit down and just relax on the floor. So every time I tighten this thing, it moves. I'm not very happy with that. Why is it moving? Wish I had one more hand here, man. Let's see if we. Let's maybe tighten the middle one first. And then that one. No, Terry, I was undercover tonight. I was driving in the wife's car. Big Red is in for its annual holiday at Ford. So for those that don't know, Big Red is I drive a F-150 fire engine red truck, and it's having a lot of issues, and it's under warranty, and so it's been back at Ford now. I'm gonna lie to you, I think probably at least 6-7 times. Sometimes it spends even a whole month there. It's now been there for 3 weeks, and they still cannot find the problem. So they're now going to rip out the whole transmission, which I'm grateful for, because if they rip that out, they got to put it back together, and it actually then gets a proper service. While if that's not where the fault is, at least it gets a full service, which is great news. Sure. One thing about building the printer like this and actually recording it is you can't stop and go and chill and do other things. You're streaming. You should finish the project, which is quite nice, because it actually puts me on a pressure to get this printer done, which I actually need to get it done, over and done with. I want to get onto this printer as quickly as possible, because that other printer sitting over there in the corner in the tent is just consuming space and doing nothing for me. So actually, trying to have a look at it. I'm actually squeezing this a little bit. I want to put a old cloth there. Should have done that ages ago. Yeah, I've got 1 or 2 marks already on the printer. Got some character already. Right. This requires a standing position. Yeah, Robert, I almost want to tell you, you can't build this printer easily without this corner squares. It's going to make your life so much easier if you do have them. Not just that, I actually, when I built up the Creality, that was also quite nice to have a decent set square, because you'll be surprised how many printers, the vertical gantry is not square to the base, so it's angled. So as your print head moves up, so your layer spacing is changing, because you're actually moving at an angle. Instead of moving 90 degrees, you're moving 89.9, 89.8 degrees. And so that makes a big difference when you get to about 200 or 300 high. Why don't I like that corner? That corner doesn't feel right. Do that again. Yeah. No, so too, this one doesn't need a tent. It is its own tent. It's fully enclosed. So at the beginning of the stream, I showed people on the side here. I've got these enclosures, so it's going to be fully enclosed. So it'll be able to generate heat inside, and I'm going to put two 300 watt PTC heaters into it with fans to actually heat up the dome, the inside up to a certain temperature, so that when I print ABS, I don't have that issue. And that's why that one broke, because I was heating it up and I actually overheated the internal electronic components on that one. I don't need to repeat that again. That's definitely something I don't want to repeat again. So yeah, it's this one's fully enclosed, and the motors and the electronics actually sit on the outside of the printer, not in the heater chamber. The only thing that sits inside the heater chamber from an electronics perspective is the what we call the extruder, where the hot end is, where the plastic actually comes out, and there's a motor over there. Yes, that does sit in there, and there's a little board over there, but that's far less susceptible to any injury in terms of heat compared to the other components. Yeah, it doesn't do much function. It doesn't work as hard, and extruder motors can actually the mini motors actually are built to handle the heat better. They can run hot. I'll turn one of these on the side now, and then you'll see this is pretty much the height of the machine, but this is the 4 outer corners of this printer. I think I'm tightening more closer to 4 knuckles, white knuckles, because feels like it. Looks like I'm missing a plate, a corner. Oh, there it is. I was going to say, wonder if Mr. Fig actually did all of them. Well, we did it together, so it would be me as well. I don't even know if Mr. Fig is online anymore. He hasn't said anything for ages. Sure. Terry, why don't we bring your printer here one day and we do a live stream? We upgrade it one evening. You've got all the parts. Shouldn't take more than 3 hours. Or are you also not a camera guy? I'm not a camera guy, but I'm bluffing you tonight, definitely. Right, almost there. Almost there. Almost there. It's taking some time to finish this last piece. I don't think we're going to go beyond putting this together tonight. That's where we're going to call it a day. And then tomorrow it becomes exciting, because tomorrow it becomes a structure. It becomes a big structure. And then at some point we're going to do all those wirings. That's going to be interesting. Quite interesting doing the wire. So I decided with RatRig you can purchase the main board with the printer, but I decided not to go that route because there's a newer model out, and it's not totally supported by RatRig yet, but it's pretty much the same as the old model, and there are quite a few people that have started using it. So I thought, you know what, I'm not going to buy a board and then 3 months down the road, sorry, I never bought it. I just going to buy it now, and I'll bite the bullet. Whatever I need to figure out and redo or change settings, I'll just do it. I've done enough board setting up a printers electronically, so I'm sure I'll conquer it without too much of a challenge. But I'm using BTT Victory Tech's new Octopus Plus EZ board. It is got 101 different connections on it. It is super nice board, and it's got the new the drivers. If you ever look at drivers on a board, the drivers are what pretty much move the motors. Okay, these drivers on this machine are got built-in heat sinks that are purposely wrapped around the actual electronic IC, which is the driver itself, and therefore it is 100% cooler than the old method. Now the old method probably not bad, but they didn't bring out this for no reason, and I think it's just a better design. It also, you can't plug the driver in the wrong way anymore. That was one of the big problems in the past. People were blowing the drivers by plugging the stuff on the board the wrong way, and you'll see. I'll show some examples when we get to the electronics as to different types of boards and how you can easily mess it up. And then I'll show you the different types of drivers that you can buy, and you'll see it's the new one's quite good. I'm also going for a different type of SSR. I'm going to try and do it into bed with a different component, and I'm also, as I said in the beginning, I'm going to put, instead of just a 500 by 500 bed on, I want to put a 300 by 300 bed as well in place. So I need to put special connectors in place where I can easily disconnect the bigger bed, connect the smaller bed, and plug it in, and it should be very simple. Yeah, I haven't seen anybody do it, not that I'm aware of, and it's going to be a challenge, but it's something that I want to do, because I don't want to run 1,500 watts when I can run 500 watts for a print. That just makes no sense. Okay, so let's give you perspective. Yes, that is the height of the printer. It is now officially, from where the table stands, taller than what I am. Let's give it some more perspective. Let's do a side view. Right, we flip this up. We look at the old printer. Okay. I'll try and I can't put it inside. It doesn't fit inside. So there it is. It's quite a bit bigger. You can't even see it. I've got to tilt the camera up even further. Ridiculous. Let's see. Let's get the camera slightly up. Okay. There you go. So give you a perspective. It's there. If you think that was the printer on the old one, I can go 300, about 280 high on that printer. This one I'm going to be able to go up to about 500 high. In any case, I think that's where I'm going to call it a night. We have a quick look at the documentation. We're up to the port where we've put those plates on, and I now need to start putting in the mainframe and start putting in the side elements now. So we will do that tomorrow night, and we'll see how far we get tomorrow night. There's no goal to finish by a certain amount of time. The only goal is we should finish. So thank you very much. For those that are watching now, and for those that are going to be watching in the future, leave comments. I'll try and answer some comments on the YouTube streams, and if there's any information I can give, sure. I have my personal company's email address on there at the moment as a temporary solution, but we are busy putting together desertsands3d.com. That will be up and running soon, and the intention is that I'm going to print the three printers in the market. I'm going to try and get into that market as well, to print those parts for people that want to print, and then I also want to get into a further market where I'm going to be printing advertising for companies maybe that need modeling done or something like that, and I can print it for them. I want to deliver that type of service, so we'll see how it goes. Hopefully that's something in the future. For now, thank you very much. Thanks for the support from the friends, and we shall see you tomorrow night if you're willing to sit around for another 3 hours. Have a good evening. Cheers.